Question 10. A certain forest contains only trees of a particular species. Deepak wants to make a random sample of 5 trees. He numbers the trees from 1 to 7, 8, 4. Then using his calculator, he generated the random digits. This is a crazy thing, isn't it? He formed 3 5-digit numbers. He took the first, second and third digits, followed by the second, third and fourth. Bizarre. Explain why he omitted 810 from the list. Lots of you got this right. There are only 724 trees, or whatever it is. 784. So there isn't a tree number 810. That there aren't enough trees. Only 784 trees, and 810 is greater than 784. Fairly obvious. Lots of you got one mark. Explain why the sample is not random. Okay, there's a very particular reason that the sample is not random. And actually, you've got to be careful how you answer this. So it's not okay to just say it's not random because it's not random, or because he didn't use a random sampling method, which I think a couple of people said it's not random because he didn't choose the numbers randomly. Well, you're kind of just rephrasing the question. The problem with it is that the second number is not independent of the first number, because he's reusing the digits. Does that make sense? So the number 478, that tree, depends on the number in the first one, and it affects the number in the second one. The numbering of the trees are not independent. That's the key thing. Each number is not independent of the next one, or of the previous one. Or each number is related to the next. I'm not convinced by the arguments that you tried to put forward that certain groups of numbers would be more or less likely to appear than others. Because actually, given the way that he selected his random 7, 8-digit number at the start, I don't think it is true to say that numbers that were less than 100 were less likely to appear than other numbers. So I think it's not about that, it's about the numbers affecting the other numbers. Right, now we're on to a lovely hypothesis test. The mean height of all trees is known to be 4.2 meters. He wishes to test whether the mean height of trees is less than 4.2. He now uses a correct method to choose a random sample of 50 trees and finds their mean height is 4. It is given that the standard deviation of trees in the forest is 0.8. So we're saying that we need to establish our hypothesis test, don't we? We're saying that the null hypothesis is that the mean height of trees hasn't changed. The mean height of trees in the forest is the same as the population mean, so that is that mu is 4.2. He wants to test whether the mean height of trees in the forest is less than that. So he's testing, is mu less than 4.2? Where mu is the mean height of trees. Remember, we need to define what we use in our hypothesis test. Okay, and we need to use mu for that rather than any variation on x. It's mu that we're interested in. If h0 is true, then our sample distribution, and remember we use x bar to denote the sample distribution, it's a normal distribution. The mean is 4.2. Now this is where we need to alter the standard deviation, or the variance, isn't it? So because it's a sample, we've got the original variance of 0.8 squared, which we're going to divide by the sample size. So that's what we're working with. Now we want to test whether we want to test the result that he got, or more unlikely than that. That's what we're interested in. So what we're looking for is what is the probability that x bar is less than 4.0, because that was the sample, that was the value that he got. And we want to test that or more extreme. That's what we're looking at in our hypothesis test. So we're going to go back to the calculator. We're doing a normal distribution this time. We're doing a lower bound of minus an enormous number. We're doing an upper bound of 4. Let's put these bits in carefully. Sigma is 0.8 over root 50. 0.8 divided by root 50. And mu is 4.2. And if we test that, it gives us a value of 0.0385. Okay. The significance level of this test was the 2% significance level. So we have to compare that with 0.02. Okay. And now we need to interpret what we've got from this. So what we found is the chance of getting this result that we got, or something more extreme, is greater than 0.02. It's more than a 2% chance of getting the result that we got. It would needed to have been less than 2% for it to be significant under that significance level, but it's more than 2%. It's quite likely for us to get the result that we saw, that he saw from the sample of trees. So there's not enough evidence to reject H0. Do not reject H0. And now we need to summarize. So what we're saying here is there is insufficient evidence. We're being careful not to make a firm, solid statement, but there is insufficient evidence at the 2% level to suggest the mean height of trees is less than 4.2. And there we go. That actually, for 7 marks, there's not an awful lot going on there. You need to structure that really carefully again. So again, you're getting 2 marks for your hypotheses. You are getting 1 mark for defining x as being normal with those parameters and doing x less than 4.0, so that comes together. You're getting a mark for 0.0385. You're getting a mark for comparing that to 0.02. You're getting a mark for saying that you are not going to reject H0. We should be saying do not reject H0. We shouldn't be saying accept H0. Because remember, we're not making those kind of definitive statements. But they will allow you to say accept H0. So you could get away with that. And then you get a mark for your final conclusion to say in a non-definitive term that there's insufficient evidence to suggest that the mean is lower. You're not allowed to say, for example, the mean height is not less than 4.2 because you haven't made that kind of definite conclusion. There we go.